Functions are a math operator, a math relationship between one variable and another. So basically a function is, let's pretend this shape, this kind of machine represents a function. As we input a value into this function, the function is going to process that input and it's going to give us an output. Let's put this into a better perspective by using a real function. Let's make this machine a little bit more complex now, and let's put a panel with a function. And let's say the function is y equals 4x. Y equals 4x is a function. And how does the function work? We need to put an input. We need to write an input value for this function. In this case, let's make x equals 2 the input. So we input x equals 2 into our machine, into our function, and what happens is instead of having y equals 4x, we now change it to y equals 4 times 2. We replace the x for a 2 because x equals 2. Then this function is going to process this information or basically do the calculation, which is 4 times 2. And the function is going to give us the output, 4 times 2 equals 8. So as we input x equals 2 into this function, the function gives us an output of y equals 8. So when x equals 2, y is equal to 8. But let's do one more problem to practice even more. The more we practice in math, the better we understand. Let's put another function into our panel. This time, let's try y equals 7x to the power of 3. We need an input. Functions works with inputs. We have to put an input, write an input into the function. And let's use x equals 4 this time. Let's put it into the function, and what's going to happen is the x of the function is going to be replaced for 4. So instead of having 7x to the power of 3, 7x to the power of 4. And we have to let the function process this information, or basically do the calculation. 4 to the power of 3 is 64, and 7 times 64 is 448. So as we input x equals 2, we have an output of y equals 448. So the answer is 448. And this is how functions work. As we change the input, the output is going to change as well. Depending on the input we write into the function, the output is going to be different most of the time. Sometimes the output is the same. But we will review that in later lessons. Now, these two sets of numbers represents the inputs and outputs of a function, of any given function. In this case, this is just an example. The first variables, the first numbers, which are the x, these are going to be the inputs. As we input these numbers into the function, we're going to get this set of numbers on the y, which we call them the outputs. But how can we be so sure that these two sets of numbers represent a real function? For this, we must follow a rule. Every input must have one output, but it cannot have more than one output. What does it mean? Let's view a couple of examples. Let's do first. -8, as we input -8 into the function, we get an output of -7. As we input -1, we get an output of 5. Remember, this is an example function. There is no real rule here. This is just so we can understand when a function is true, a function, or is it not. Then let's say 4 also gives us a 5. And finally, an input of 7 gives us an output of 9. Now, every input has an output. And even though -1 and 4 have the same output, that is not a problem. The important thing is that every input has an output, which means, yes, this is a function. So we prove this is a function. And before we move on to the next example, let's also review a little bit of the notation, especially because we're going to need it in the next unit when we start doing, in the next lesson when we start doing graphing, and it is the input We can also call it the domain of the function. And the output, we also call it the range. As said, this is just concept information that we will use in future lessons. But let's do one more example. Let's change these relationships. And now let's say that, well, -8, that one is still related to -7. So -8 input gives us an output of -7. Now -1 gives us an output of 5, but also gives us an output of 9. 4 gives us an output of 9, and 7 gives us an output of 9. The fact that 3 inputs gives us the same output of 9, that is not a problem. Not a problem at all. That's totally fine. The problem here is this too. -1 is having 2 different outputs. This is not allowed. Every input cannot have more than one output, meaning this is not a function. And this is one of the ways we have to prove whether a relationship between numbers is a function or not.